So today, physics, biology, three big names: Ilya Prigozhin, Francisco Varela, and Rupert Sheldrake. Let's go now to complexity in physics, and as I said, the one name to remember is Ilya Prigozhin. He did his entire life research into what is called fluid dynamics in physics. Fluid dynamics is the dynamics of fluids, of liquids, right? So what he did was he had a liquid, water, he put things in there, he started to heat it, which makes it dynamic. If you take water, you put it on an oven, and you heat it, it starts boiling, right? So you bring in dynamics, things starts moving, and he studied his entire life what happened in those fluid dynamics. That study, which was basically the study of nonlinear dynamic models, brought him to what I explained to you in the previous course. The importance of the initial state, the period doubling. You've seen 1 attractor, 2 attractors, 4, 8, right? That's period doubling. The fact that your attractors seem to double at a certain point. So first one, you know, the simulation I showed you. There are two concepts that are highly interrelated that basically gave him his Nobel Prize, which is the irreversibility of time principle annexed the constructive role of time. And what is the argument of Prigozhin? It's very mathematical. It's irreversibility of time. What he says that within a classical Newtonian paradigm, which means a fixed time-space concept, whenever you have a construct, a model, you know what happens today, you know what's going to happen tomorrow, and therefore you know what happened yesterday. It's all causally interrelated. Hence, he says, why is it possible that you have seemingly a better access to the past and you don't have the same access to the future? We know perfectly what happened in the past. We don't have any clue what happens in the future. In a real Newtonian world, you should be able to have exactly the same certitude on the future as on the past. In other words, he says, the whole Newtonian approach of a fixed time-space doesn't hold. Since if it would hold, then you would exactly know what happens tomorrow. In a Newtonian world, there is no need for anticipation. You know what's happening tomorrow. Now, reality, of course, is clearly non-Newtonian. What he says is, why doesn't it work? So that's the observation he does. There is irreversibility of time. You can't reverse in time. You cannot turn the time around. So therefore, time seems to play a role. And that is what he calls the constructive role of time. What he says is, in everything what happens, time plays a constructive role. Not the variable time, but the fact time. I give you an example. If you want to make coffee, you take coffee powder and you take water. If you would put that at one moment all together in a pot, you get nothing. You can try that if you can always try what I say. It's not dangerous, and if you don't believe me, you'll see that I'm right? It doesn't work. What do you do if you want to make coffee? You put powder in a percolator, in a coffee machine. You put cold water in a coffee machine, you push on the button, and you wait. And while you're waiting, there is a process starting, and it is that process that takes time, and it is that process that is taking time that is necessary to make you something which tastes like coffee. There is no other way to make coffee. Secondly, if you make coffee using a coffee machine, or you make coffee with a pot with your hand, and if you don't believe me, you just try that, you get a different taste of coffee with the same coffee powder. How comes? Since it is a different constructive role of time. You switch off the machine, and again you get an arrow of time. Ilya Prigozhin in the interview will call that the arrow of time. You'll get an arrow of time. You'll get time as a constructive principle. Constructive in doing what? In cooling down the liquid. And after an hour you get something which in some countries is thrown away since it tastes, according to some cultures, awful. And in other cultures it is sold as iced coffee. Now, if you taste that iced coffee, though it is the same liquid, it will taste differently. Why? Since again that coffee went through an arrow of time. Time has played a constructive role in creating another taste. Now, then you've probably all done in your life, if not, please do it. The same error, you take a cup of cold coffee, you put it in a microwave, you push on the microwave. What do you get? Something very awful, isn't it? And then you do the second error, you take the same cold coffee, you heat it on a stove, you get also something awful, but differently awful. There are two other concepts that I'll comment after the video. The first one is that behavior far away from equilibrium, and Ilya Prigogine comes at the end of the clips I want to show you to that point. Behavior of a system far away from equilibrium is different from behavior of the same system close to equilibrium. That's my motorbike of last time, right? If I don't push my motorbike to the edge of chaos, then it will not be able to go through the curve at the speed that you want it to go through the curve. So far away from equilibrium, that motorbike is capable of doing things that close to equilibrium he could not do. So a system out of equilibrium, away from equilibrium, is able to create different things. You'll see in the interview that what he did as research was he had certain fluids, he was heating them, and far away, so when they were quite heated, far away from equilibrium, they changed colors, which in his fluids was impossible close to equilibrium. And that is where he didn't invent anything new, he just proved that what we knew out of simulations was also true in the physical world. And the second thing that he brought to us was the fact that knowledge is built up each time over and again, bottom up. That means, and we get back to that when we talk about the biologies, knowledge does not exist in your head. Knowledge is something that each time when you know it, you need it, you recreate it. Even your age is not stored in your memory. By the way, you don't have a long-term memory. You don't have a long-term addressable memory. Any information that you will need is not stored on an addressable place in your brain. The brain is continuously preparing to give the answer, to reproduce, physically reproduce the potential answer to the potential question that I might ask. Since I was talking about age, you ran the risk that I would ask your age. In order to prepare the answer, you were preparing the answer. I didn't ask you to do that. That's how the brain works. Then the brain stores that age in a short-term memory. You have a short-term memory. Short-term memory cannot keep much than 4, 5, 6 items. That's what you can keep in a short-term memory. Some people keep it for minutes, some people keep it for an hour, but that's what it is. All the rest is reproduced. That is why you can reproduce whatever you want to. There is no memory. You reproduce your memory. So if you want to believe for the rest of your life that you had a sad youth, you're going to have a sad youth for the rest of your life, and the other way around. Nobody knows how physically the reproduction of memory, so to say, works. Keep that in mind, since what Prigogine observes in his fluids, that knowledge is built up each time over and again. The taste of my coffee is built each time over and again when I switch on the machine. Now that will become extremely important when we talk about complexity in biology. Don't forget that we are all biological beings. A company is nothing else than a neurobiological colony of all biological entities that interact. That is what a company is. Now you might like to describe that in markets and people and salaries and whatever, but it's not reality.